Okay, this is question 7 then from the November 2018 Higher Paper 1 Maths, following on from my last video. This is circle theorems. It's 4 marks on that, 2 marks for your written communication and saying what you've done. Okay, and we've got to find angle x. So the first rule we're going to use is that when you've got the sort of arrow shape, the angle at the centre is double the angle at the circumference. So angle AOB is 74 times 2, which is 148. Okay, and then a little sentence that just says double angle at circumference. Okay, how does that help us to do angle x? Well, the next thing you've got to spot then is if it's an isosceles triangle here. How do I know it's isosceles? So if we say that OAB is isosceles, this is all for your OCW marks, and I know that because OA and OB are both radiuses for the circle, which means they're equal. So to find angle x then, it's take 148 away from 180, which is 32, and then 32 divided by 2 because we've got the same angles both sides of that triangle. So 16 degrees either side, so 16 degrees in there, 16 degrees there. Okay, as long as you're explaining your steps along the way. Question 8 is relative frequency. Relative frequency is like probability, except you get your numbers from experimental data. This is somebody who's rolled a dice. It says in the question that it's biased. Okay, and they've run it 1,000 times, and they've counted and measured the relative frequency of getting a 6 each time. So the first question, fairly standard first question, it says which one is the best estimate. On a relative frequency question, the best estimate is always the last one. Okay, and that's because this is the one with 1,000 trials, and 1,000 trials will always be more reliable than 800, 600, 400 or 200 trials. So 0.32 would be our best. So you always take the last point, and the reason is because the more trials you do, the more reliable your data is. Part B, how many 6s were thrown in the first 600 throws of the dice? So if we go to where 600 throws is, and read off the value, you get 0.34. If you want to, you could think of that as a percentage. 34% is 34% of, which is times, the first 600 throws. Okay, so then you've got to work out what 0.34 times 600 is, which is 204. Okay. How many more 6s were recorded for these 600 throws than you would expect? Okay, well, if it was a fair 6-sided dice, you would expect that 1/6 of the 600 throws would come out as a 6, which would be 100 times. And we've got 204 times, so that means we've got an extra 104 times of rolling a 6 than we would have expected to get. Okay, so relative frequency, exactly the same as probability really, except it's all got from experimental data. Okay, number 9, forming and solving your own equation. They've given us space for a diagram, so it's a cuboid. It's got sides which are x long. So I put that one there. It's got 5 long, and we've got 7 long. I'll leave the units off for now, put them back on the end. And we know that the total surface area, remember, is the area of the individual surfaces added up, is 142. So there are 6 surfaces on a cuboid. They come in 3 pairs. So this first surface is x wide and it's 7 tall, so 7 times x, 7x would be the area. Okay, this one is 5 wide and 7 to 5 times 7 is 35, so there's no algebra in that one. And then on the top, we've got x wide and 5 in that direction. 5 times x is 5x. Now don't forget, of course, that there's another 35 hidden in behind there. There's another 7x hidden on the back there. And there's another 5x hidden underneath there. They come in pairs. Okay? And we know that the total surface area is 142. So we make an expression that says that when you add all of this up, you get 142. So we've got 7x and another 7x. We've got 5x for the top and 5x for the bottom. We've got 35 on the right side and another 35 on the left side. And we're told in the question that it equals 142. Okay? Well, all we've got to do now is tidy all of that up. So we've got 24x plus 70 is equal to 142. If we take the 70 over and take it away, that gives us that 24x is 142 minus 70, which is 72. 24x equals 72, and then if we divide 72 divided by 24, x equals 3. 3 24s make 72. Okay, that's quite a nice question. Sometimes you get a volume one. The only difference with volume, you'd probably end up with a quadratic to factorise and solve, or if it was paper 2, get your calculator out and use the quadratic formula, but that's quite a nice one. Question 10. Transformations then. So it describes fully the single transformation. When it says single, it means you're only looking for one of the four. So it's either an enlargement or a rotation or a reflection or a translation. It's not both. You can't say that it's been enlarged and rotated. We're looking for a single transformation. Now, if the shapes are different sizes, then it can only be one of the transformations. It's got to be an enlargement. So for your first mark, you just need to say that it's an enlargement. Okay. Now we go from A to B. The shape got bigger. Okay. The original triangle was 2 squares wide, and the new one is 4 squares wide. It's twice as big. So if we start by saying that our scale factor is 2, it's not quite exactly 2, because as you can see, the triangle's been flipped upside down. The only way that can happen is if the scale factor is actually minus 2. Okay? So doubled and flipped. For the third mark, you need to find the centre of enlargement, and the best way to do that is to sort of get your ray lines out, your enlarging lines, and join up the corresponding corners. So that one matches to there, this one matches up here, and where they meet, there, that is your centre of enlargement. That's the best way to find the centre of enlargement, and you give it as a coordinate. So the centre of enlargement is the coordinate 4, 6 for 3 marks. Okay, so say what it is, say by how much, and say from where. Enlargement, scale factor minus 2 because it's double and upside down. Centre enlargement, like I say, do your ray lines, where they meet, where they cross, that's your centre of enlargement. Okay, graphical inequalities next. Use the axes below, find the region which satisfies the following inequalities. So there's 3 lines, so it's going to be a triangle, and then colour it in, clearly indicate your region, so shade it at the end. One of those lines we can draw straight on, the other 2 are going to need a table. The one we can draw straight on, and for now I'll just pretend that it says equals, x equals minus 1. That's a vertical line down through minus 1. So let's put that on, I'll put it on in red. So there we go, down through minus 1. It says more than in the question, so when I come to do my colouring, more than would be to the right hand side. Okay, stretch that line a little bit longer just in case we need it. Right, for the other two lines, we're going to need a table. And that's what this little bit of space at the top is for. So if I bring this one down here, I think the first thing I'd like to do with that is rearrange it into the form of sort of y equals. So let's forget about the inequality for a second and make it an equation. To get y on its own, I would need to take the 2x to the other side. It would change to a minus, so 1 minus 2x. Then I'm going to make a table. You can get away with two values, but it's risky because if one of them's wrong, your whole line will be wrong. So generally, I always do 3 values. Then if one of them's wrong, you should notice. So I'll do the 3 easiest values I can think of, which is 0, 1, and 2, and hopefully they will fit onto the grid. Okay, so it's 1 take away 2x. So 1 take away double 0 is 1 take away 0. 1 take away 0 is 1. Okay. Our next one is 1 take away double 1. So double 1 is 2. So 1 take away 2 is minus 1. And then it's 1 take away double 2. Well, double 2 is 4. So 1 take away 4 is minus 3. So our coordinates are 0, 1, 1 minus 1, and 2 minus 3. And we can join them up with a ruler. Let's have a look. Go to type that up a little bit. Okay. And let's go back to our inequality. It says less than, I think it was. Board's frozen. There we go. It's a less than sign, so less than is beneath that line, underneath. So we can put arrows downwards. And then the last one is, well, pretend it's an equals again. So y equals x. I mean, you can make a table if you want to. Hopefully you don't need to. 0, 1, 2. Y equals x, 0, 1, 2. It's a sort of a 45-degree perfect diagonal line. 0, 0, 1, 1, 2, 2. Y equals x is a line that you should know anyway when you do reflection. So let's set that up there, stretch it down on the other side as well. And I'm going to bet that's a more than. Yeah, that's a more than sign in the original question, so we're going above that line. And then you've got to just shade the region which matches all of your arrows, your more thans and less thans. So we're going to the right, underneath, and above. So colour in there. This is shading the region that shows your answer. Okay. And the lines themselves are included as well, because they're more than or equal to, or less than or equal to. So the lines are included. If they were just more thans and less thans, the only thing you'd do differently is when you put your lines in, you would do a dashed line rather than a solid line, because the line itself would not be included in the region in that case. Okay, so that's question 7 to question 11. I'll stop the video there and we'll pick up question 12 in a new video.